Now I am going to limit this shaking to 10% of the text width. For that I have to measure this width, and it's a lot of fun or a lot of pain depending on your point of view. The problem is that we have two different sizes. There is a width of an element that contains a text and the width of the text itself. The first width is easily obtained by one of handy methods: client width, offset width, scroll width, or getBounding client rect. But in many cases these methods will tell us nothing about the second width. Of course, with inline elements it will be much simpler, because inline elements tend to acquire the width of their content. So for example, if you call client width on an inline element, you will get basically an actual width of a text plus a padding, if an element has a padding. So you just subtract this padding and you get the second width. But of course I'm speaking nonsense here, because anyway we have to support block elements as well, and they are more complex in this regard. Block elements usually expand to the full width of their parent, a document body for example. So this time client width will tell us the width of this body element or whatever is the parent, and it's completely useless for us. So we need a different technique to measure a text inside block elements, and hopefully such technique will be applicable to inline elements as well. There are plenty of weird solutions on Stack Overflow. This can be an enjoyable read if you are curious. I'll pick this solution, which surprisingly makes use of the Canvas API, and more precisely its measureText method. It seems like a most up-to-date answer, and besides I just enjoy the word canvas. Basically this solution is fairly weird as well, because measureText is not designed to measure a text within existing elements. This method rather means, before drawing some text to the canvas, let's imagine how large it would be. So we are kind of creating an imaginary text, and we have to manually specify its attributes: the actual string of text, its font size and font family. Let's copy-paste this code and hide it in a function that should take an element as an argument and return a width of a text which resides in this element. I'll store an element in a variable for convenience. For now my goal will simply be to console log a result. This return value will be an object with multiple measurements, and we are obviously interested in width. To make this function work properly, we need to extract a text content from a given element. And then we need the font styles. For that we have a window getComputedStyle method. It gives us a ton of different styles, including font size, font family, and there is also a shorthand font property, which contains both family and size. So we'll use this font property. Run it, and now we have a number which looks quite believable. Let's reduce the font size and run it again. We can see a number which is twice smaller. So now I am pretty confident that we get a real width of the text. Now finally let's use this new knowledge to limit the movement of the text. But first I have to confess that currently I am really overusing this random number. It's meant to determine both the direction of the movement and the distance of this movement, and it makes the code hardly maintainable. So let's use two different random numbers. I'll also remove this console log to create a constant instead. And another constant to store this 5% limit, which is expressed in pixels of course. Now it's time to modify this condition. This means that the text will move to the right not only according to the random number, but also if the text has gone too far to the left. and it will move to the right only if it hasn't yet gone too far to the right. This condition allows the text to make one step beyond the limit, and once it finds itself beyond the limit, it necessarily makes a step backwards. Now it seems to be shaking within the limits. I'll make it happen 10 times faster to double check. Still looks fine.